Okay, it's right at 1:30, and I'm going to go ahead and get started. Thank you for joining us today. I know we had some changes. We initially wanted to have a session where we would have you come to the vault and meet us out and provide you with some resources and talk about the upcoming units. But we had to change that because of lots of things going on at the school, and we want to be certain that you have that time available at your school as well. So I'm just going to tell you a little bit about our time today. It is a short period of time, but we're going to be focusing on the sixth grade and seventh grade EE standards, and in particular, the most heavily tested ones that are coming up in the next unit, the expressions and equations unit. There's a couple of documents that I want to share with you, so that is why I wanted to be sure that I had everybody on and that they had the chat option available, because I was going to be sending you some links to things. I haven't had anybody send me a chat message yet, so I'm not certain if you'll have access to them. So what I'll do is I will pull up my screen and share my screen so that you have access to some of the things. But hopefully you'll be near a computer so that you're able to work together with these things. The first thing to discuss is the upcoming units, and we're going to take a look at our website, the Central DPS site. So just one second. So we're going to actually go to that site. And that site is, of course, central.dpsnc.net. This is the home page. Hopefully, everybody has been here at least once, and this is pretty much where all of our resources are housed, as far as our unit maps and suggestions for resources to use. So once you're at this page, of course, we go to the middle school courses. And then that takes us to our unit maps. Now, I do want to bring to your attention a couple of things if you've not explored our website, and that is that there are some practice sites here at the bottom. I know a good bit of people use 10 marks and IXL and things like that. Here are some additional resources as well for practice. And then here are some interactive sites that we are going to be using. In particular, we're going to be taking a look at this Glencoe manipulative site. It's very good for the EE unit. And then also there's some exploration things and worksheet generators when you need additional practice, just so you have taken notice to that. So as we look at grade 6, we are looking at not the RP unit, but we're looking at unit 3 expressions. And so within that unit addresses NS4, EE1, EE2, EE3, and EE4, I believe. So it's quite a bit of information. So how did we narrow our focus for today? Number one is looking at the test specifications, and I will be sending this link to everyone as well. North Carolina Department of Public Instruction, they have released the specification for the resource and the EOG that they take at the end of the year, and it lets us know kind of how heavily these particular standards, how frequently would they be seen on the test. So the test for 6EE, as it's opening up, we'll see exactly how much of the EE is going to be on the end of grade test. So this document, of course, released by DPI. If we're looking at EE and all that comes in Unit 3, we see that the most heavily tested question or strand is going to be EE3 with 4 questions. So that's going to be our focus for 6th grade today. And then also looking at our 7th grade unit from our website, we're going to be working with 6th and 7th grades combined today, and you will see that for 7th grade, the EE unit looks at some of the same standards for that grade level. So EE 1, 2, 3, and 4, and then B and A and B for that strand 4. And we're looking again to focus on the most heavily tested strand so that we can kind of discuss how it looks and what questions can support that. And so as I pull up that same document for 7th grade, and I will share these with you, we see that in the EE area, the most heavily tested is EE4. So for 6th grade, we'll be focusing on EE3, and for 7th grade, we will be focusing on EE4. Now, hopefully, this next document that I pull up, you have referenced and have seen before. On each content area's webpage, there's an unpacking standard from DPI. So we're going to take a look at 7EE4 and see exactly what that standard is before we get a sense of how we're going to pull resources and look at things to support that unit. So it's taken a little bit of time to come up because it is a lengthy PDF. I will go ahead and put this link in our chat area on our Hangout. And so hopefully those of you that have access to the chat, you'll be able to click that link. So as we look at EE, EE4 is talking directly about using variables to represent real world math problems using simple equations and inequalities. So literally one of the examples here is literally them modeling out a situation using what I would call a tape diagram and also looking at things algebraically. So let's look at this same pacing or unpacking guide for 6th grade and find out exactly what 6EE entails. Hopefully I'm not going too quickly for you. So for 6th grade, the EE standard is talking about what? So let's look at this unpacking guide. The unpacking guide gives up a little bit more detail than the standards themselves as to what all is entailed in meeting that particular standard. So for EE, we will look and find that EE3 for 6th grade, computer's frozen. EE for 6th grade is talking about applying the properties of operations to generate equivalent expressions. And again, you see a kind of a similar diagram here. So that is why the focus of our discussion today will be using algebra tiles to support 6th grade and 7th grade instruction in the equations and expressions unit. Okay, I will also share this link in our chat section, and I will be sharing a Google folder with you with just the information that we've discussed today so that you have access to it. So since I haven't been able to get any feedback, is anybody, I'm going to pause and see if anybody have access to their camera, or does anyone have access to their microphone so that I can kind of hear exactly who's on the line and talk to you about your use of algebra tiles. Anybody able to respond to a chat message or talk to me? Is anybody able to talk and or chat me? Okay. Well, we're going to move on. Hopefully you are able to see everything and be a part of the discussion as far as the EE is concerned and why those were selected. So the next thing that we're going to do is just jump right into some examples of how to use algebra tiles to support the 6EE standard and the 7EE standard, which is 7EE4 and 6EE3. Now, I'm not certain exactly how much everyone has had the opportunity to use algebra tiles. Algebra tiles is something that oftentimes get used at high schools for the intro or foundation courses, and sometimes with the middle schools, but we sometimes kind of get lost in working with those. So today we definitely want to show you and talk to you about exactly how we will use these for the 6th grade classroom. A link that I'm going to provide for you is going to be the link to the Glencoe resources. So if you can hear me or see what I am saying, that link is also on our website. So the link itself, I'm going to put in the chat option, but I'm not certain if everybody has access to see it. But the link is also available on the middle school page underneath teacher interactives. It's the Glencoe manipulatives. That's one of the resources that we'll be using today. For the first activity in dealing with 6EE is going to be some questions that I pulled from the Walsh series. So we do have our Carnegie Learning, and we definitely are going to be using those resources, but I wanted to use something a little bit different so that you can kind of see of ways to use stations, but also use manipulatives, and also be able to reserve some of your resources in case you need to use additional resources from Carnegie Learning along the way. So this wall series activity is free. It's a sample and it is online. And it's basically letting you know that what the goal is, which is to develop the concepts and skills of evaluating and simplifying expressions. And it also, as you go through this, it lets you know that there's activities involved and that there's stations involved. So the next thing that we're going to do is definitely take a look at and model some of these situations. So I am going to have us, if you have access to your computers, we're going to be taking a look at some of these expressions, and we're going to be able to talk about how we would use this. Well, I guess you'll be listening to me because I can't get anyone to be able to connect to their mic. I think they might be having some issues with it. So on the very top, let me just go back to this screen so that you see. At the very top of the screen, you should see a little microphone and a camera. And if you hover over that, it will say unmute or mute microphone. And that is how you turn your microphone and camera on. For those of you, I just got an email from someone saying we don't know how to turn our microphone and camera on. So try that. And if not, just send me another email. Or you can also give me a call. Anybody, you can give me a call at 21315. And then I can talk you through that briefly. So if you do not have access to the chat and you do not have access to the computer and you're doing this as a large group, hopefully on your individual devices, you will be able to go to our website, the Central DPS website. And then again, we're going to be using the Glencoe manipulatives first. And it is just very big. And you're able to project it initially if you want to as an introduction. And then also it's a little friendly as far as some of our devices are concerned. So in particular, we're going to be working with algebraic expressions first. And then we're going to go ahead and march on into solving equations for 7th grade. So you see that the content really does connect. Without them being able to understand how to combine like terms, they really would have difficulties in solving two-step and one-step equations. So we're going to select a work mat. Here it gives you lots and lots and lots of options, and it's very, very neat, and it's free. So we're going to start with a blank mat for right now, since we're just doing algebraic expressions. And then from your manipulatives, we're going to use our algebra tiles. And as you see, it has the polynomial algebra tiles that you will get into when you start talking about in 8th grade and also in Math 1. But for middle school, we'll just be focusing on, for the most part, we'll be focusing on looking at these for today. So I'm going to start out with just something very, very basic. And I know that we have varying levels of expertise on how you have used the algebra tiles. It just depends on your experience. So I am going to take my smart board tool here. Hold on one second, excuse me. Okay. Okay, sorry about that. I had an email coming in, and I want us to be able to start out with several equations. So right there at the very bottom, you see that there is the hand tool, the text tool, straight line tool. There's lots of tools that come with this free resource. I love it. And I'm just going to, I guess I better use the text tool since I have such horrible handwriting. We're going to start out with a couple of algebraic expressions. Very simple, just so we can get the modeling down. So we're going to do negative 2x plus 2. The next one that we're going to do is going to be 16 plus x. The next expression is going to be 20 minus 2x. And we'll just use those three. So for these expressions, what you could have students do is either have a die that they can roll and then they would evaluate this expression, or we can talk about some other things. So right now we're going to talk about simplifying and evaluating. So for this particular task, students would be given a value for the expression, and they would have to plug it in and tell the values for each of these expressions. So we'll just do something basic like, ooh, I told you my handwriting was bad. X equals negative 2. And x equals 4. We'll just do those two values. That looks amazing. Okay, so if we were starting out with this expression and we were talking about evaluating it, first of all, let's look at modeling these expressions. So for a particular student, how would we model what 2x plus 2, negative 2x plus 2 looks like? So again, we would have to acclimate with the colors, and they sometimes are blue or yellow. It just depends on where you got them from. But we would just simply drag these over. So this first expression is negative 2x. So I have one negative x, and now I have another negative x, and then it's going to be plus 2. So I'm going to add out 1 and 2. So the directions for this particular activity or just problem that they will be working on is they would have to evaluate this expression, and they would have to use negative 2, substitute for negative 2, and then they would also have to substitute for 4. So if a student, before they get into the calculations or knowing integer rules, how would we set this up? How would we allow them to model what this looks like without knowing integer rules and without having any concrete knowledge of what the rules are? So we would have to talk about what this means. If you're saying that x is now equal to negative 2, then I would be replacing an x in for negative 2. So what would that mean? What would that look like? So for this particular problem, it'll be a little bit different because you have to multiply a negative times a negative here. I guess I should have started out with a positive just to show you the modeling part. But for this one, it is possible, but we're getting into talking about actually having to know that a negative times a negative is a positive. So I'm going to actually go back to that one because right now I want us to talk about modeling without you knowing any integer rules. So a couple of people took note of the fact that we are doing our expressions before we do our integer rules, and it is because I want us to take a look at the modeling part. So let's just hold off on this particular portion. Sorry about that. So let's look at 16 plus x. Because that's one we can model. And I really want to focus on showing the mathematics before getting into the rules. So let's back out. So if we're looking at 16 plus x, it would take them some time to model this, but it's possible. So I'm going to pull out 16 of these. Some people that don't have the algebra tiles, they allow the students to draw these out. Some people print them, but the good news is for all of the viewers today, you will actually get a class set of 32 algebra tiles to use in your classroom for participating. So that's why it is very important that I know who's on the call. I know that we have 8 people dialed in, and some PLCs are dialing in as one, but I definitely want to know the names of everyone who are on the line. So if you can, right now, just send me a very quick email about what school, and also who's attending the webinar, just so I have that. Okay, so we have 16 now. And then we're going to be doing 16 plus x. So again, focusing on the fact that we may or may not know the rules or algebra rules right now, the integer rules rather, but we want them to be able to show you exactly what this means. So if I'm saying that x is now equal to 4, I will be replacing this x. I've modeled 16 plus x. I would now be replacing this x with 4. So in the place of this, I got you, Chrissy. I'm going to be replacing this with 4. So again, I'm not looking at the integer rules or anything of that nature. We're going to get into that. For those students that you have are coming to you at that level 1 level, trying to hammer in the integer rules into their head initially, it's not going to work, as you already know. They really need to make sense of this. So now I have substituted in 4 for my x, literally substituted in. They can see this, and you can cover it up with however many numbers that you need to. And then now I can take a look at this. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So now I have 20. And for the student, we would just go back and say 16 plus x is what we initially had, remember? And then we actually substituted in our value of 4 for x. And so now they will be able to show you mathematically and count that 16 plus x, when x is a value of 4, is equal to 20. That looks beautiful. Just looks amazing. So I know that there are some people thinking, why in the world would I go through all of this trouble? Why in the world would you go through all this trouble? So let's talk about 6th grade. When students come to you to 6th grade, not everybody is at the same readiness level. I know that is amazing, and you didn't know that. But literally, some students still struggle with simple addition and subtraction, multiplication and division before we start talking about anything as sophisticated as applying an integer rule when they have no context of even how to multiply, divide, add, and subtract fluently without having to pause and count on their fingers or look at the ceiling. So this is allowing them to build up and have an opportunity so that they can see these patterns. They can develop these rules in their mind so that when you give it to them abstractly, it will make more sense. They have context. They've done this with their hands. They've counted with the marks. And hey, Mr. Martin, and they are able to make sense of what you are asking them to do. This particular act is really, really, really helpful, especially for an EC student, to literally, when you're saying replace or substitute, they are literally taking this quantity and replacing it, covering up that x, and it now is making sense that is what I do. I replace it. If x were 5, we would still put 5 blocks. If you had 2x, we put 5 blocks over whatever that number is. You just want to cover it up with that value so that it makes sense for them. So let's actually, since this is so beautiful, let's actually go ahead and evaluate 16 plus x using the -2. Using the -2. So I'm going to start all over. And I'm going to write that expression up here again. And my value was x equals -2. I'm getting good at this now. Okay, so if I, again, am having them, I don't want to explain any rules. I don't want to give them any type of situation. I just want to have them show me. Again, I'm going to start out with that 16. Hopefully you are able to pull this up on your computer and do it along with me. While I am doing this, for those of you that are using Google Plus, if you will take a look at your Google Plus, and you can start a chat with me. That way we'll be able to communicate. So I have James is on the line. I just sent a message to him. So if you have the Google chat, if you want to go into Google Plus and just send me a chat message, you will be able to communicate with me that way if you can't get the chat to work on Hangout. So let me quickly go through this. Great, I'm glad you're with me. So if you have that option to send a chat message, go ahead and let me know kind of if you've used algebra tiles before in the way that you've used them. How do you have a class set? How have you used them? So if you could send me a message, either email or a message on Google Hangout, that'll be helpful because I definitely want to hear from you. So I have my 16 here lined up very neatly, leaning down, and I'm going to do that plus x. So again, I'm always starting with that equation. And the good thing about this is I can make it as small or as large as I want to for adding things. So I am going to be substituting in the value of -2 for my x. So I am going to come over here and I'm going to be putting in my two negatives, which is my -2. Okay, so the discussion again then lends itself. What happens if and remember, to build up that base knowledge for students, don't go get all mathematical on them with the terminology if they don't have the background vocabulary. Of course, you want to be able to have that discussion with them on grade level using academic correct vocabulary. But here, just give situations. You know, students love when you're talking about integers, talking about money. So if I give you $1 and I take that dollar away, what does that mean? It cancels out. So talking about building up those situational things so that you can have a discussion. So I've replaced my two negatives with my x, so I can go ahead and take that away in this case. And then my pairs, as I pair up $1 and take away $1, that cancels out. So that's a 0 pair. And another $1, give and take, that's taking that away. So now what am I left with? I'm left with 4, 4, 4, and 2. So that's going to give me 14. So again, also with the students, make sure that they're still rationalizing their thinking algebraically. So we would still go ahead and write this out. I have the 16 plus x. I'm going to substitute in. 4x with the -2. If I can get this thing to draw. So here, I'm going to substitute in. So this is now 16 plus a -2. And we are going to just write it this way. Again, you can have to get more sophisticated with it, though that's a parentheses, apparently. And then looking again that and having them count. What is it? That's 14. So especially for those of them that do not have solid mathematical foundations in adding, subtracting, multiplying, and dividing, it's going to be very important that they have a way to reference and to model their thinking. Okay, so this particular activity is available to you, and I will be emailing it out to all of you that email me. So this is one of 4 stations, and so I just want to go through very quickly because I can't go through every single part, but this is talking about going from Celsius to Fahrenheit and that and what happens as we take a look at that. And I want them to be able to talk about the like terms and the simplifying before we get into that fractional thing. Because once again, once you get into that fractional thing, you know, everyone starts freaking out. So this literally walks them through this process. If you have students that are on track and ready to go, they will begin at station 1. If you have some students that still, they're strong, but they may have some calculation issues, then they can be at station 2, etc. So these vary in complexity and getting all the way down to the basic sense of just modeling to me that you know how to add and subtract, and then also them being able to simplify and write their own expressions. This one's very fun by using the cards. So not to worry, I will be sharing this with you. The kids really enjoy this. I've done this activity before, not in this district, but I've done it before in another district, and they really, really enjoy this. Yes, this will take some time. So is this something that will be one class period? If you have 50%, at least 50% of your students that I would say projected to be a level 3 or above, it will take one class period. If you do not, you may want to pick and choose 1 or 2 stations and break them up, or you may have a series of little stations set up that they only spend a little bit of time and get the work on it, but you're going to have to tailor this to your needs and your students, and you know them best. Okay? All right, the next thing that I want to jump into is now going to be the 7th grade material. And even though there are teachers on here that are from 6th grade, because I just saw Susan Heiselman just said hello, so she's on the line. Glad you joined us today. But you also want to know the connection. So you do have some students that may be ready to go on and do more complex things. So I really do want to have things available so that you know the connection, so that they can see that connection. So I'm going to be starting out with a situation, and I do need you in your small groups or individually to read over this particular situation, and we're going to talk about how to model it. So I'm going to put it up on the screen. Here it is. And I'm going to give you a chance to read over it. I won't read it to you. I know you're smart people. Oops, sorry about that. Trying to do too many things at once. I really do wish we had some of the audio available, and so that we could hear about what you believe misconceptions would be. What are some roadblocks in just reading these problems, thinking about where your students are right now? I hypothesize that one of the things will be the vocabulary. And I know that some people are saying, what? But triplets, knowing what a triplet is, or having context to know what a triplet is, may be an issue. May or may not be an issue, but it's something to be mindful of, especially with your EC and your ESL populations. You have to have context to make things make sense. Yes, that's something that you customary that you know what a triplet is, but you just want to be certain that everybody has that background knowledge. And then the next thing will be our academic vocabulary, being able to make sense of some. Hopefully we have everyone there. Less than, hopefully we have everyone there, because at grade 7 they would have been introduced to that in expressions with grade 6, and then quotient, which they also have been exposed to. Okay, so thinking about these situations, we're now going to talk about how we would model them. So I'm really going to have to get tricky so that I can show you both at the same time. Here we go. Oh, yeah. Okay, the Wilsons have triplets and another child who is 10 years old. How would we show that? What situation is that? They have 3 kids and another that is 10. So, of course, that's going to be the triplets will represent, X will represent the kids, the babies. So, triplets, and then they have another child who is 10 years old. So, of course, again, that's going to be 10. Let me pause. I'm sorry, I'm jumping ahead of myself. I'm going to actually 7th grade, go to backgrounds, and 6th grade. I want us all to do this. Go to backgrounds, and we're going to actually do an equation chart for our work map. Okay, so we're going back to that problem. Let me put it back up here. The Wilsons have triplets, meaning they have 3. And then they also have another child who is 10. So I'm going to represent that 4th child with 10. So again, the questions that you pose to students, you don't want to lead them. We do want to lead them, but you want to question them in a way that you're not giving them the answer. So if they get stuck on what this means and how to represent it, you would want to think ahead and say, okay, what questions would I pose so that they make the connection of these being the triplets, this being the 4th child? What questions would I ask? In your PLC, that's what you want to think about. What could we ask students to guide their thinking without giving them the answer, allowing them to struggle and think about it and make sense of it themselves? Okay, so now I have the babies all on the board. I have the triplets, and then I have the 10-year-old is modeled here. The next part says, the sum of the ages of the children is 37. So all of these are the children, and their age, and the sum is 37. How old are the triplets? So this is going to take us some time. Yes, I should have chose a different problem. So let me get my 37 tiles. You definitely will want to choose a problem with not that many as to be modeled. But we'll get there. Just be patient with me. And hopefully you're doing it along with me. I think that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So I am copy and paste would be a beautiful thing right now. So again, as you're doing this, you will have a set of algebra tiles to use, a set of 32 to use for your classes. You also want to get yourself acclimated to using this tool because you want to model. And for those of you in 6th grade, they don't use algebra tiles. They use 2-colored counters and things like that. So they will do the different sides, and they won't be used to knowing what the negative and the positive means. And so they do have context of what a negative number is as far as on the number line. We just have to make that make sense in this modeling sense. So you do want to kind of show them how to manipulate it and talk to them about how to make sense of this in their own thinking. So I'm going to put my 7, I believe it was, on here. 7th grade, you would hope that they have had the opportunity to model, but don't assume. I would say for a warm-up, you would have them draw out a particular algebraic expression to see their thinking. And if they're with you, then you're good to go. And if they're not with you, you will want to demo this. Okay, so the question is, I have my situation, so we always reference back. The Wilsons have triplets. These are my triplets. They have another child who is 10 years old. This is my 10. The sum, meaning I'm adding these together, of their ages is 37. I have my 37. How old are the triplets? So again, I'm trying to figure out what X is. How old are these triplets? Because they are the same age, of course. So in this particular case, we would want to figure out how we can get X alone. So that would be the question. How will you get rid of X? Well, I will get rid of X by moving over a 1 or subtracting a 1 or taking away a 1. And then it referenced back again. What does it mean to be equal? If I do something to one side, I must do it to the other. That's the rule. So we're going to go ahead and take away these 0 pairs. And we can just take them away from both sides. I won't waste time with that. There's another app that I'll show you that cancels them out. So if I took away 1 from that side, I'll just take away 1 from this side. So we can speed this up. 1 from this side, 1 from this side, 1 from this side, 1 from this side, 1 from this side. I'm sure you're enjoying hearing me say that. Did I skip? So you get the gist of what we are doing here. I don't think I kept up with my count. Sorry about that. Trying to go through this quickly. Okay. I need to look back at our problem. We had 37 and we were taking away 10. So I should have 27. But I don't know that I do. Okay, so I'm sorry to put you through that. I think I started out with not having 37 on there. I had another number, and I had to go back and add those in. So now that I took away 10 from each side, the question is still asking us, what does each triplet, how old is each child in this set? So we would look at trying to take these and match them up, trying to divide these evenly. Again, how much would one equal if we distribute our years evenly among 3 students, 3 kids? So you're able to manipulate these, but again, this will take some discussion. For those students that are on grade level, they immediately know that it makes sense to divide these up because they're the same exact age, so they should match up evenly. To some students, it would not. So we would go through this process again. So we'll just start out by giving them each 5. And as you can see, that this does take time. So you want to make sure you allot time to go through this, allot time to the struggle. You don't want to have the struggle I had with the struggle with keeping up with the counting. But it's a struggle as I try to go through this expeditiously, try to go through this so I'm making a good use of our time. Because I do have one other thing that I wanted to show you on the graphing calculator before we disconnect. So I'm going to start out, again, like I said, just giving them 5 apiece and kind of seeing what that looks like. And I realize that I have more left. And so that is the good thing, again, about letting students hypothesize. How old do you think they would be based on what you have and letting them test that out? Well, that's not old enough. So maybe I'll give them 2 more each. And let's see how this works. So they each have 2 more. It looks like I still will have some left. So I have 6 left, so I'm just going to give them 2 apiece because I am noticing now that I'm dividing this evenly. So again, a student that have strong conceptual base, they will pick up on that right away. A student that does not, you want to develop that by allowing them to kind of struggle through this and questioning them until they realize they will have that aha moment to say, okay, I'm giving the same amount to each one. When you give the same amount to each one, what are you doing? Oh, I divide. So again, having them make sense of this without you telling them the rule. So I am going to go ahead and write this out algebraically, what we discussed. So we had the 3 kids of the triplets plus another child that was 10 years old. And together, the sum of their ages was 37. So in this case, we have already algebraically, without having the rules of talking about equations, but they should know them, but we've already taken away 10 from each side, remember? And I struggle with that part, but we did it. We did it. After I took away 10, ooh, that looks amazing. After I took away 10, I had 27 on this side, or I was supposed to, but we'll just say we did. We had 27 on this side. So now as I move these tiles around, I am noticing that I'm simply dividing this out by what? We're dividing it out by the number of kids we had, which would be 3. Okay, so algebraically, as far as the operation here, I'm going to divide this by 3. Now, again, you want to be careful to say every time you see this, remember, we're not having them do any generalizations. We won't say that every time X is multiplied, you would do the opposite. We want to have them derive that and get to that point on their own. And then now, what does one child equal? They would be able to go and see that one of these children is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 years old. Ooh, that's an ugly 9. Hold on. 9. Amazing. So again, this to teachers who are crunched for time, you're going to say this takes a good bit of time. The question in the long run would be, if 6th grade doesn't take time for them to understand, to combine like terms and what it means by having them model it and make sense, if 7th grade doesn't do it for the equations, it still doesn't make sense, they go in 8th grade. We would just keep doing the same thing over and over again. So allowing them this time, picking some juicy problems that are reasonable, because definitely don't want to do a 37. We want to start out with something small that they can model, and then allowing them, questioning them so that they can make sense of this, so that this now makes sense. It does make sense to do these steps now that I've gone through this process, okay? So I will be sharing this particular activity with you as well. The 7th grade, I had several different situations that we would model before we got into the abstract of them just solving. So it's a temperature problem and etc. about losing points on the test. But I will email those to you for the sake of time, since we're wrapping up at 2:30, because I do want to show you in the calculator pretty much how to check and have them look at simplifying algebraic expressions if they're still struggling. So we'll look at these same 2 problems. Once they've modeled them out, they've written them out algebraically, how to go in and check in your calculator to be certain that it's true. There is an app, Wabbit Emulator, and I will be sending you the link to that as well. It's not one that I'll be using today, but it is a free download for Android, Apple, and for just Windows. And this is what it looks like. I will email you the steps to it. It's pretty much a calculator emulator. I have a different version. I'm going to be using the TI Smart View, but this is just as good. So for those of you that use the calculator in your classroom, but you don't have a way to project it, instead of putting it under the document cam, you can download this Wabbit emulator, and you'll be able to show them exactly what it looks like on their calculator, just like it looks like on yours. So this is one option for you as well, and I will send you the links to this. It is free as well. I'm all about free. But for my sake today, I'm going to be using the SmartView software. And I gave away a SmartView to a teacher that attended professional development, and also to a BT teacher. So we do give things out sporadically. Me and Amy, we love to give you gifts, but we love for those gifts to be meaningful and affect, instruction in the classroom. So my SmartView emulator is going to come up in just a second. And I want you for sixth grade to think about that first problem that we did. And for seventh grade, I want you to think about this, the particular problem that we just talked about the triplets. And we're going to talk about how a student, without you confirming, how they will be able to go in and check themselves using the calculator. Now, for most part, everybody is pretty much against using the calculator when we're dealing with expressions and things of that nature, because we think that it hurts the students. If they're taught to use it appropriately, then it will be absolutely fine. Absolutely fine. So for the first equation, if I can remember, I believe, and I'm pulling it up now, just give me one moment. We'll do this seventh grade one, then we'll go back to the sixth grade one. So when we have the equation, they've written this out in a manner that makes sense to them. How do you know it's true? How do you know you're right? Well, they have their model there, of course. But what if you made an error and it doesn't make sense? They're able to go back in their calculator to check. So this is the check. And I'm sure most of you are aware of this, but this is just something that I want to make sure we go over. There is a way to put store numbers into the calculator so that you can be certain that an equation is true. So we're just going to go over these quick steps, and then we'll do it for an expression as well. And then we'll wrap up. And I'll tell you exactly how to be certain that you are sure that you get your class set of algebra tiles, so that you can use them in your upcoming units and have them in students' hands to model expressions and equations. So the Wilsons, back to the Wilsons. We found out from our modeling that we believe that the triplets are 9. We believe that there were 9, and this was our equation. Remember our equation? It was 3x plus 10 equals 37. And we believe that each triplet is 9 years old. So we're going to start out with that value. So in your calculator, if you have them, we're going to do 9, and then the store button is right here above the on button, and we'll just do X. And we're going to hit enter. And that's letting us know that it's indeed stored at this point. So we know that the 9 is stored. And I'm going to put in that expression. 3x plus 10. And we're going to go in this math matrix here. And we're going to get our equal sign. I didn't hit second. So second math, excuse me. And we're going to get our equal sign because we're trying to test to find out if this is indeed true. So I went through that quickly. So a second math because we're trying to test to see if this equation is true. So we're going to click enter. And we've already stored our value of 9 for x. And we want to know if 3x plus 10 is going to give us 37. And we hit enter, and it tells us 1. So 1 meaning yes, you're correct. And then 0, of course, meaning nah, you got something wrong. So let's try that. Let's say if I got by mistake, because my name is Chanel and I moved away the numbers too quickly and got confused. Let's say I got 11. I believe the triplets are 11. So I'm going to put in, again, remember how we store it. We're going to do the number first. So 11 and store. And then we'll do the value x again. And you can choose any of the letters that are on here. Just have to remember which one you've chosen. And I hit enter, and it gives me that 11. I know that it's stored. So I'm going to try it again and say, do I believe that 3x plus 10 is going to be 37? And this time, no. 11 wasn't right. So again, this is a second safety net for your students. You can't, if they don't know how to translate the algebraic expression, they're already behind. So this is coming into the fact to know that they have to have worked that problem out and they have to have solved it in order for them to make sense of it. Remember, at grade 7, they're going to be pretty much looking at whether or not they can translate and solve multi-step equations. Those are the concepts. In 6th grade, we are looking at whether or not they know the integers. But if they don't, they're not solid on the integers, we still want them to be able to use their calculator as a check. Okay? So we're going to clear this out, and I'm going to do that same thing with our evaluation questions. So we had, I keep clicking this. We had, no. We had our question. I'm just trying to remember it off the top of my head because I have too many screens going on right now. But I believe it was something to the effect of 20 plus x, I believe. And then we wanted to substitute in, or 16 plus x, and we wanted to substitute in for 4. So we would do the same thing. We would say, I want x to equal 4, so I'm going to do 4, and then store, and I'm going to select x and hit enter, and that lets me know it's stored. So for any type of situation, all of those algebraic expressions that came up, they will be able to constantly use x and not have to go and repeat it over and over again. So 16 plus x in this case would be 20. And the negative 2x plus 3, it will give you negative 5. So it's still using this value. As long as you've stored it in, you'll be able to substitute in so that they can check. Again, this is a way to check. So if students always have to model their thinking and show you their thinking, this calculator isn't taking away, it's not taking away anything. If I don't know how to multiply 4 times a negative 2 and get a negative 8, then it's no way I'll get this answer. Even if I got it in the calculator, I wouldn't be able to make sense of that to show you the steps. So as long as we always have our students available and ready to model their thinking, the calculator is only as like a pat on the back for you, so they won't keep constantly raising their hand. Am I right? Am I right? Am I on the right track? Am I on the right track? The question just came in from Stacy. Stacy, is there an emulator for the TI-15? I would have to look into that. It is my hope, and I have lots of hopes, is to get the graphing calculators into all of the hands of students 6 through 8. So gradually I will be having us transition to that as long as I can kind of make a bark and make it known that it's important. I think it's important for these students to get acclimated to this as soon as possible. There's lots of things that this calculator can lend itself, especially in the analysis of the SP strands for grade 6, looking at histogram, looking at central measures of tendency. There's lots of things, because remember, they need to know how to analyze those graphs and not always how to calculate them will be how they're assessed. So I do want these calculators to move down to grade 6, 7, and 8, so that by the time to 8th grade, they'll be so solid. Our math 1 and our 8th grade scores will go through the roof. So I will check into that. That's definitely a good question, and then I will check to see if there's a TI-15 emulator. Are there any other calculators that people use? If you will send me an email, I will check into it. Most likely, I'm going to say no. But there could be someone written a code just like they did for the Wabbit emulator. This is something that somebody made up, and they just, came up with that. So it may be possible for us to look around and see what else we can find. But that is a good question. Okay. I have 60 seconds left. And I hope that you found this valuable. Again, the whole intent of today was really for us to talk about modeling and the thinking behind moving the order of some of our units, in particular at grade 6. You do notice that they are talking about expressions before they get into the integers, and it's because I want them to model first. They struggle so much with integer rules because it doesn't make sense to them. And if we get them to model their thinking and combining like terms and taking this negative tile and this negative tile and putting them together, oh, I have two negatives, and getting them to model that thinking, we will have less struggle as we introduce the more abstract rules of why you multiply a negative by a negative and it's a positive. We'll be able to talk about some of those things a little easier because they'll have context of what it looks like to add and subtract, and also to divide integers. So hopefully, again, you can see my thinking there. It really is about them modeling their thinking and being able to explain it versus being able to memorize a rule. So that is why we see as they travel from grade to grade, we sometimes have to pick up that slack, and sometimes they struggle, and it's because they don't have the conceptual understanding to carry it over from grade to grade. Are there any at this time? Going to pause and see if there's anybody that wants to send me an IM or an email. Okay, well, it's 2:31 and I definitely want to let you out on time. I know your time is valuable. I appreciate you being here. Please be sure that you email me again. If you haven't emailed me already, just email me again and let me know exactly who is here, exactly the school and what representatives you have. Also, if you want to provide some feedback on other types of professional development as far as modeling is concerned, because that's big in our EE strand and also in our NS strands as well. But any feedback you want to provide will be definitely welcome as well. You will get a short evaluation to complete, and they'll also confirm your attendance today. And you will get credit for this session in what is it called now? True North Logic. And this webinar, let me see, there was a question that just came in. Will this webinar be available at another time? This webinar is recorded. And so that's why I wanted to make sure I took my face off and my screen. This webinar is recorded and you can view it at any time. And then also I'm more than welcome to come to your PLCs and work in your departments. Bring your tiles out and we can do some activity together and talk about how it can be used and how we foresee kids struggling or not struggling with it and how we can make it academically challenging at that level. So any other questions? That was a good question that came in. Any other questions? Again, thank you for being here. Have a great day. Enjoy your early release. Signing off. Have a great one.